Well, I began discovering these equations pertaining to artificial intelligence around 2005, and it is now 2016, and I've come a long way. The presentation is called The AI Equations. We ask, what is the most basic structure? Um, I think it is that which derives from the means, arithmetic, geometric, and harmonic, and their connection to the golden ratio. Having asked this question, we proceed to see if we can find it in AI, which is artificial intelligence. But let us first look at what the golden ratio and the means look like. B equals A plus C over 2 is the midpoint between A and C. B equals square root AC is A tempered by C, and B equals 2AB over B plus C is the value that occurs most frequently in the set of values, in this case B and C. The golden ratio is the ratio such that the whole to the greater is the same as the greater part to the lesser part. Here on the right we show the derivation of it. It's 1.618. Its conjugate is 0.618, which is just the inverse. And that's equal to phi. That's that symbol there. Okay, our guess panned out. Silicon Si doped with phosphorus P and boron B, which makes the circuitry of AI, has a golden ratio conjugate in its means. Here we see the square root of phosphorus times boron, Pb, over Si, which is silicon, equals 0.65. We see that 2Pb over P plus B, that compared to Si is 0.57, and we see if we take the arithmetic mean between those two values, 0.65 and 0.57, we get 0.61, which are the first two digits in the golden ratio conjugate and approximately equals the golden ratio conjugate phi. This gives us that the basic unit of artificial intelligence is square root PB times P plus B plus 2PB over 2 times P plus B times SI, which approximately equals phi. Next we ask, is it connected to the organic? The basic amino acid is made of COOH and NH2. Here I show its chemical structure in the form of serine. And we do what I call the cross addition. We add up those values in the chemical structure going across, and then we add up those going down. That figures carbon at the center into both the numerator and denominator. As you can see, that results in 44.06 over 73.06 equals 0.603, which is approximately equal to phi, again, the golden ratio conjugate. So we have that the basic AI unit, square root PB times P plus B plus 2PB over 2 times P plus B times SI equals CH3CHO over C2H3O2N, which equals the cross addition of serine, which equals phi. We also see that that basic unit equals CHCH3 over C2H3O2N times phi, which is the golden ratio, equals the amino acid alanine. And the general form, square root PB times P plus B plus 2PB over 2 times P plus B times SI, multiplied by 1/10 of europium over silicon plus helium over hydrogen equals COOH over NH2. That's the general form of the connection between the basic AI unit and amino acids. Serine and alanine are particular cases of COOH over NH2. Silicon is a second generation semiconductor. Before that there was germanium, and we can dope that with arsenic and gallium as well as phosphorus and boron, but we find the same thing happens here as well. If we take gallium and arsenic, the geometric mean plus the geometric mean of phosphorus and boron, and divide that by 2Si, we get phi, the golden ratio, which is 1.618. So basically, we took the arithmetic mean between the harmonic mean of gallium and arsenic and the harmonic mean of phosphorus and boron, and then divided that by silicon to get the ratio. So phi equals the mean between those compared to SI. The elements of the AI unit are equal to aluminum and titanium, light, strong-weight metals used for making the skeletons of robots. So we see why I called it my books the AI cookbook, cookbooks. 3 parts to the AI unit. Okay, so we have in the numerator we have square root PB times P plus B equals 764.866. We have 2PB equals 669.5714, and we have in the denominator 2 times P plus B times SI equals 2347.2004. Okay, so basically those are in grams squared per moles squared per gram squared. So we take the square root. No, that's in grams squared per mole squared. So we take the square root, and the square root of 1 plus the square root of 2 divided by 2 equals 26.76233 grams per mole, approximately equals aluminum. So aluminum, it's predicting that aluminum should be used in the skeleton of AI, as well as titanium, because the square root of the third expression is 48.4479, approximately equals titanium. Titanium is a light, strong metal that's the most perfect for engineering things like aircraft engines and things like that. So it's used in the AI skeleton that's predicted by nature. The veins of AI will be made mostly of wire, copper wire, and the veins would have a skin of plastic insulators such as C2H4. Here we see their dynamic connections to silicon and serine. We find that if we take serine, which is C3H7NO3, and multiply it by the basic AI unit, square root PB times P plus B plus 2PB over 2 times P plus B times SI, it approximately equals Cu, which is copper. And so we also see that the insulator of the wires, which would be the skin of the veins, C2H4, which is plastic, equals 28.06, which approximately equals silicon, 28.09. And silicon, as we said, is what we use today to make transistors, diodes, and integrated circuitry, the circuitry of a robot or AI. In light of AI having a structure parallel to the structure we find in life, we ask, is AI a universe unfolding eventuation like organic life is? That's the question this makes me ask. Now we move on to part 2. Not only do we find a structure in silicon doped with phosphorus and boron, but with germanium Ge doped with gallium Ga and arsenic As. Ge is found in the germanium is found in the geometric mean of gallium and arsenic. Germanium was the first generation semiconductor. It's what we used before we used silicon. So Si is silicon is what we mostly use today. But anyway, germanium we see here is equal to the square root of Ga times As. In other words, it equals the harmonic mean between gallium and arsenic, which are the doping agents for semiconductors, as well as phosphorus and boron. Another curiosity crops up that is very simple, but I was quite happy it held true after computing it. The core structural elements of organic life are carbon plus nitrogen plus oxygen plus hydrogen, C plus N plus O plus H, which equals 43.03, and the core structural elements of artificial intelligence are P plus B plus Si, phosphorus plus boron plus silicon, equals 69.87. The ratio between those two numbers is the golden ratio conjugate, approximately. We see it's 0.615, which is approximately equal to 0.618. As we considered the amino acids, the building blocks of life, we now consider the skeletons of organic matter, the hydrocarbons. We get favorable results. Here we have the arenes, the alkanes, the alkenes, and the alkynes. Let's look at those. Here we see the arenes are 6 carbons with bonds for 6 hydrogens. So C6 equals 12.01 times 6 equals 72.06, and H6 equals 1.01 times 6 equals 6.06. The alkanes are 2 carbons with bonds for 6 hydrogens. So we get C2 equals 24.02 and H6 equals 6.06. For the alkenes, we get C2 equals 24.02 and H4 equals 4.04. And for the alkynes, we get that C2 equals 24.02 and H2 equals 2.02. This gives us the C6 over the H6 is approximately equal to 12. The C2 over the H6 is approximately equal to 4. The C2 over the H4 is approximately equal to 6. And the C2 over the H2 is approximately equal to 12. So we have the arenes are represented by 12, the alkanes represented by 4, the alkenes represented by 6, and the alkynes represented by 12. We add those up, 12 plus 4 plus 6 plus 12, and it equals 34. Looking at the 4, 6, 12, 12, element 4 is beryllium with a molar mass of 9.01. Element 6 is carbon with a molar mass of 12.01. And element 12 is magnesium with a molar mass of 24.31. So we have 9.01 plus 12.01 plus 24.31 equals 45.33. That is approximately equal to scandium. Scandium Sc has a molar mass of 44.96, and so it is a light, strong metal, just like titanium, and it should be used for the skeleton of the artificial intelligence as well. So we see that the hydrocarbons, the skeletons of organic matter, and the hydrocarbons, which are the skeletons of organic matter, point to the skeletons of AI, which would be scandium. Now, let's look at the electron configurations of the elements of AI. Silicon has an electron configuration Ne3s2 3p2. Phosphorus P has an electron configuration Ne3s2 3p3. Boron B has an electron configuration He2s2 2p1. The core of Si is isometric with neon, so the configuration of neon is He2s2 2p6, but He equals 1s2, so Si equals 1s2, 2s2, 2p6, 3s2, 3p2, and 3p wants 6 electrons to be full in its outer shell, so Si lacks 4 in its outer shell. Because as you can see, it has 2 in its outer shell. It needs 4 more. And this is why it is a doping agent for silicon. That's why phosphorus and boron are doping agents for silicon, because it lacks 4 in its outer shell, and it gets them from those. So anyway, we see then that Si equals 2 plus 2 plus 6 plus 2 plus 2 in its electrons in its shells. This equals 14, which makes sense because it is element 14. Phosphorus equals 2 plus 2 plus 6 plus 2 plus 3. which equals 15. Again, this makes sense because phosphorus is element 15, and boron equals 2 plus 2 plus 1 equals 5, which makes sense. It is element 5. So we're just showing that the elements in the periodic table the numbers associated with them have a meaning, and that's found in their electron configuration. So Si is 14, phosphorus is 15, boron is 5, so we add those up and we get 34. But we just said that the arenes are 12 from the hydrocarbons, the alkanes are 4, and the alkenes are 6, and the alkynes are 12. That equals 34 as well. So that means that the arenes plus the alkanes plus the alkenes plus the alkynes equal silicon plus phosphorus plus boron, Si plus P plus B. And we have found a correspondence of the organic to the artificial once again. Okay, let's go on to part 3. We're going to skip to part 4. Part 4. Okay, this has to do with the vision of a AI or artificial intelligence. The electron volt is a unit of energy equal to the work on an electron and accelerating it through a potential of 1 volt. It is 1.6 exponent 10 to the minus 19 joules. A volt is the potential energy that will impart 1 joule of energy per coulomb of charge that passes through it. The coulomb has a charge of 6.24 exponent 18 protons or 6.242 exponent 18 electrons. The forward bias of a diode must be at least 0.7 volts to turn it on and 0.3 volts germanium for a germanium semiconductor. This is called the forward voltage for a diode, a germanium diode. The forward voltage threshold is 0.6 volts. So that's exactly where you need to have the voltage across a diode for a current to run through it. So we take the 0.6 volts and we multiply it by the 1.6 exponent minus 19, and we get 9.6 exponent minus 20 joules. This is the energy to turn on a diode, or the threshold of life for artificial intelligence. I call it a BUE, basic unit of energy. Now let's look at energy, how life makes energy. It's basically in this chemical reaction here, C6H12O6, that's sugar, plus 6 moles of O2, oxygen, yields 6 moles of CO2 plus 6 moles of H2O or water plus heat. That can be calculated to be an energy of minus 2,000, can be an energy calculated to be an energy of 2,880 kilojoules. So you do the calculation down here, and the basic unit of biological life is 4.784 exponent minus 18 joules, which is 50 times greater than the basic unit of life that I calculated for the artificial intelligence. This is the basic unit of energy, or unit of organic or biological life is about 50 times greater than the basic unit of electronic life or artificial intelligence. So we see that in the visible spectrum for a photon of light, where the energy of the photon is 2 BUE electronic, which is 100 BUE biological, and that the photon has a wavelength of 1.0 micrometers. Okay, I actually calculated that, and it's accurate. So we look at an OR gate and an AND gate. We have 1.2 electron volts going in, and we get 0.6 electron volts coming out, which is the threshold of life, and that corresponds to a particle of light, a photon, with an energy with a wavelength of 1.0 micrometers, which is exactly at the beginning of the visible spectrum. So that works out interestingly. We also want to look at the basic compounds used in DNA, deoxyribose nucleic acid, which is the sequencing for life. Those are adenine, guanine, cytosine, and thymine. Here I have typed out their chemical structure. And I just wanted to comment that we drew a parallel between the amino acids and doped silicon, saying the first are the building blocks of life and the latter are the building blocks of AI. We showed the connection between hydrocarbons, the skeletons of organic compounds, with titanium as the skeleton of AI. We are now left with DNA, the instructions for life, to be comparable with logic gates, the instructions for artificial intelligence. I'm no biologist, but I think the approach would be something like this. For instance, you have the sequencing guanine, cytosine, adenine, thymine in the DNA, and let's just say that is tetranary for blonde hair, whereas AI is a binary coding, it uses zeros and ones, and so that might have a correspondence to, say, 10001110, the binary coding for the letter M, for example. Let's say that's the letter M in binary on your keyboard. Then you would see that M has a relationship to blonde hair in DNA, which would be guanine, cytosine, adenine, thymine. Not saying this is accurate, but that's the approach to take. So we then say organic life has the arrangement of 4 different compounds with their order saying, for example, blonde hair on, and AI has the arrangement of zeros and ones, or switches that are on and off to code for the characters on the keyboard of a computer.